Question 21 is also a questions on the pedigree. So you can see here, the questions actually told us that this is an autosomal allele. Yeah, this is an autosomal allele. Yeah, so that means that you don't have to determine whether this is sex-linked or autosomal already, right? The questions already told us that the red hair, the hair color, is actually controlled by autosomal. Okay, so now what we need to do is, based on the pedigree, you have to figure out whether this is autosomal dominant or autosomal recessive. What the question want is, they want to ask they want the type of inheritance for the red hair. Okay, so you have to figure out this red hair is dominant or recessive. Yeah, dominant or recessive. So you have to look into the pedigree. Okay, so one of the way to identify dominant or recessive is to see whether they skip or don't skip the generation. Yeah, whether it skip or don't skip the generation. Okay, but this pedigree is a bit troublesome. Okay, if you analyze it properly, later you will see that. Okay, but before that, I would like to remind you all on this. Right, this is one of the common mistake or common careless mistake, right, that a lot of students will do, right, which is this one. You look at this one, yeah. So this individual 5 and 6, right, is not the offspring of this pair of parents. Okay, they are not the offspring. Yes, you can see that there's no line connect them. Okay, so these two, they are not. Okay, they are not. Okay, so that's why when you look into the pedigree to see whether it skipped a generation or not, you cannot take this generation, then this generation, and this generation. You cannot look like this. Okay, why? Because these two, they are not the offspring. They are not the offspring of this pair of the parent. So that's why you cannot see them like this. Okay, you can't say, oh, they don't skip the generation. No, you can't read like this. Okay, reason because there's no line. They are not the offspring. Okay, so this is one of the careless mistake that a lot of students will do. So please be reminded, all right? And please be extra careful. Okay, so that's the first thing. Yep, so now we look at the pedigree now, yeah, whether it skip or don't skip the generation. Okay, if you look at this family tree, obviously they don't skip. Okay, you can see that the grandparent, one of the grandparent is having the trait, right? Is having the red hair. So one of the the son in the second generation is also, yeah, having the red hair. Okay, and then the son in the third generation is also having the red hair. So it seems like they don't skip the generation. But if you look at another way, if you look at this way, okay, if you look at this way, yeah, if you look at this family tree, then what happened? You will see that this one have one red hair. Then after that, there's no red hair. Yeah, there's no red hair. And then after that, the other children will have the red hair. One of them is having the red hair. And then the next generation is not having the red hair. So it is having the red hair, don't have red hair, having red hair, don't have red hair. Okay, so this part of pedigree is actually showing that it is skipping the generation. Yeah, it skipped the generation. Okay, so which one we should choose? Whether this is don't skip or whether it skip. If it don't skip, then it is dominant. If let's say it skip, then it's recessive. Okay, so it is impossible to use this point in order to figure out whether it is a dominant or recessive. Okay, so that's why we have to use the second identification point. Yeah, the second identification point, find the pair of the parent in the pedigree where both of them are not having the red hair. Both of them are not affected, but they are producing a child that is having red hair. That means at least a child, at least one offspring that is affected. Okay, look for that. Okay, or you can also look for the two parents are affected. That means both of the parents are red hair, and then give birth to the child at least one child that is not having the red hair, that's having the brown hair. Okay, you look into that. Okay, so in that, you try to find either both parent not affected produce a affected child, or you look for both parent are affected produce the unaffected child. You look for that. Okay, so in the whole pedigree, if you look at it properly, you analyze it properly, okay, then you will see what? You will see that yes, we can find one, which is here. Both parents are not affected, okay, but then they are producing at least one child that is affected. Okay, so yeah, that is actually one of the key points for us to identify whether this is dominant or recessive. Okay, so before we proceed, okay, so this question, it is actually autosomal, right? So it's autosomal, that means that it is going to follow the normal Mendel model. Okay, and it is related to pedigree. So pedigree must be monohybrid cross, yeah? Okay. All right, and to solve this type of question, whatever Punnett square calculation, we will use the type 1 method. Yeah, the type 1 method. Okay, so done. Now we have to settle this. Yeah, the question A here. Okay, type of inheritance for red hair. So this red hair is dominant or recessive. Okay, so like what I said just now, we have found a pair of parents that's not affected, but produce a child that is affected. Okay, so this will mean what? This will mean that this is definitely recessive. Okay, because this one you can refer back to the identification point in the mind map. Yeah. Okay, when both parents are not affected, but they produce a child that is affected, then that means that this must be the recessive. Yeah, this must be the recessive. Okay. So that's why for A, okay, so the red hair, yeah, the red hair is autosomal recessive. Okay, then of course the reason you can say, yeah, because both unaffected parents is producing at least one affected child. Okay. All right, then next we'll move on to B. Yeah, next we'll move on to B. So before this, if let's say you are not sure why, you can try to use the Punnett square to prove that. Yeah, you can use the Punnett square to prove that. Yeah, okay. Both unaffected parent, how they actually produce an affected child. Okay, and if let's say it's dominant, if this is dominant, then it will be affected both affected parent produce unaffected child. Okay, yeah, so try on that. Yeah, you try on that and then try to understand. Okay, right. So this question, yep, A, it will be autosomal recessive for the red hair. Yeah. All right, then next we will look at B. Okay, we will look at B. Yeah. So for B, what are the genotype and phenotype of the individual 3-9? Yeah, individual 3-9. Yeah, 3-9 is here. 3-9 is here. This is 3-9, yeah? Generation 3, individual 9. Okay, so they are asking for genotype and the phenotype of the 3-9, yeah? So if you want to find the genotype or phenotype, first thing first, yeah, still the same thing. You have to find the genotype of the parent first. Okay, so where's the parent? Parent is here. Okay, so this would be the parent, yeah? So individual 2, 3, and also individual 2, 4. Okay, so these two individual is the parent. Okay, so first thing first, write the parent first. So parent would be individual 2, 3. Yeah, individual 2, 3. Yeah, so yep, this one, individual 2, 3, and then individual 2, 4, and also the individual 2, 4. So these are the two parent. Okay, for us to figure out what is the genotype of this individual 3-9. Yeah. Okay, so for the parent, individual 2-3. Individual 2-3 is a mother, and this mother is having brown hair. Is having brown hair. Okay, so brown hair, we now know that brown hair is actually dominant. Yeah, brown hair is dominant. Yeah, so that means that this individual will be having at least one dominant, right? One dominant allele, brown hair. Okay, then next for 2-4, individual 2-4, the father. The father is a red hair. Yeah, it's a red hair. And now we already know that red hair is recessive one. Yeah, we know it that red hair is recessive. So if red hair is recessive, then that means that we can confirm the genotype of this father already. Yeah, we can confirm the genotype of this father. So he's a red hair. So that means that this individual must be having, yeah, must be having homozygous recessive. Okay, so once we know this, okay, then next. Okay. Over here, you can see that this pair of parent is producing the child, okay? And one of their son is actually having the red hair. That means that having the homozygous recessive trait, okay? So based on this, now we can try to think here, okay? So this one you don't need to put into calculation, but you can do the confirmation in the draft paper, okay? So the parent 2-3, okay, can have two type of the genotype, right? Right? He can have two type of genotype. Either the father, the mother can be homozygous dominant, or the mother can be heterozygous as well. Okay, since this father, the genotype is confirmed. Okay, the genotype is confirmed. So that means that this father can only produce one type of gamete, which is the recessive B. Okay, so now we look at the Punnett square. If the mother is homozygous dominant B, that means the mother can only produce one type of the, only one type of the gamete. And then the father can only produce one type of gamete. Okay, then in that case, that will means what? That will means that none of the offspring will have red hair. Okay, if this individual is homozygous dominant, then it is impossible for the son to have red hair. It's impossible. Okay, so that means what? That means that this is definitely out already. This is definitely out. Okay, then if let's say the individual here is heterozygous, then this individual is homozygous recessive, then what would it be? Yeah, what would it be? So this individual is going to produce two type of the gamete, and then this individual is going to produce one type of gamete. So with that, when you do the cross, you will see that it is possible for the son that's been produced to be brown hair. At the same time, there are chance for the son to be red hair as well. So it tally with what is shown in the pedigree. So that's why now we can confirm this individual 2-3 must be heterozygous. Well, must be heterozygous, yeah? So that's why now we can confirm now it is heterozygous. Where is heterozygous? Okay. So once we confirm the genotype for both of the parent, then now we can do the Punnett square. Right? We can list all the gamete and then do the Punnett square, yeah? Okay, so this first parent, right, is going to have two type of gamete, yeah? Can produce two type of gamete. Then this parent 2-4 can only produce one type of gamete. So when we do the cross, okay, so you can see that, yep, there are chances for the son to have the brown hair. There are chances for the son to have the red hair. Okay, so this would be the F1 generation. Okay, so done with this. The question is asking for genotype and phenotype of individual 3-9. 3-9 is here. Okay, so this 3-9 is the F1 generation one. Yeah, 3-9 is actually one of the F1 generation. Okay, so this would be the ratio. Yeah, this would be the genotype ratio. Yeah, so that's why with that, for the individual 3-9, okay, the genotype the genotype of the individual 39, okay, it would be heterozygous. Cannot be this one because the individual 39 is having brown hair. Is having brown hair, so that means that must be this. Yeah, he must be this. Yeah, he must be this type of genotype. So it is heterozygous. Then how about the phenotype? So this is heterozygous. Heterozygous will means it is a brown hair. Yeah? So 39 is a male, so that's why you have to write he is a brown hair male. Okay, so even though the questions didn't ask for the gender, but it is stated, it is shown in the pedigree. So that's why, yep, you still have to put that to be safe. Yeah, still have to put that. Brown hair, male. Okay, so with that, yes, that is basically all for these questions.